Open two browser profiles on the same laptop, log into two different accounts, and do nothing else wrong. Same proxy, same machine, nothing shared. Within a day, one account is fine and the other is asking you to verify a phone number, or it is just gone. You never reused the password, you never touched the same cookie. The platform still tied those two accounts together, and it did it with a technique that never asks your permission and never shows up on screen. It is called browser fingerprinting. Today I want to walk through how it actually works and how anti-detect browsers try to answer it. Vilken cookies and Hagishans. I run real proxy and cloud phone farms, and I test anti-detect browsers the way people who juggle a lot of accounts actually use them. Multilogin, GoLogin, Cameleo, Ads Power, Dolphin NT, and the rest. So this is not theory I read somewhere. It is the thing I fight with every week. I am going to keep this defensive and third person the whole way, meaning how sites build a fingerprint and how these browsers respond. Not a recipe for tricking any one platform. What a browser fingerprint actually is. A fingerprint is just a bundle of small facts about your browser and your machine, collected quietly and meshed into one identifier. No single fact is secret. Your language setting is not a secret. Your screen size is not a secret. The trick is that when you stack 30 or 40 of these little facts together, the combination gets specific enough to pick your browser out of a crowd. The same way no one detail on a face is unique but the whole face is. A site does not need your name. It just needs a value that stays the same every time your browser shows up. The passive signals, the first family of signals is passive. These are things your browser hands over just by connecting before a single script runs. Your IP address is the loudest one, and it carries a lot. The network behind it, the rough location, whether it looks like a home line or a data center. Right behind it are your HTTP headers, the user agent string that names your browser and operating system, your language setting, the order those headers arrive in. Then there is your TLS fingerprint, the exact way your browser opens an encrypted connection, the cipher list, and the order it offers them in. That pattern is surprisingly consistent for each browser build, and a server can read it on the very first handshake. Here is why passive signals matter so much. You do not choose them, and you cannot easily fake them without breaking something. If your user agent claims to be Chrome on Windows but your TLS handshake looks like Firefox on Linux, that mismatch is itself a signal, and a loud one. Sites do not just read each value, they check whether the values agree with each other. That idea consistency between signals is the whole ballgame, and it comes back again and again through the rest of this image. The active signals, the second family is active. This is where a script runs inside your browser and asks it to do small jobs, then measures exactly how it does them. The famous one is Canvas. The site tells your browser to draw some text and shapes onto a hidden canvas element, then reads the pixels back out. Your specific mix of GPU, graphics driver, and operating system renders that image with tiny differences, sub-pixel stuff no human would ever notice, and those differences are stable. Same machine, same drawing, same result, every single time. Hash that image and you have a sticky little ID. Canvas has a whole family around it. WebGlade does the same trick in 3 dimensions and leaks your graphics card vendor and model on top. The audio stack can be measured the same way. Feed a sound through the browser audio engine, and the exact numbers that come back depend on your hardware and software. Then there is your font list, which sounds boring until you realize the exact set of fonts installed on your machine is oddly personal, a record of everything you have ever installed. Add screen resolution, time zones, how many CPU cores the browser reports, how much memory it claims, and the pile of little facts gets tall fast. And the list keeps growing. There is RareBK, a feature meant for voice and video calls, which can quietly reveal a local network address if the browser lets it. There are the media devices attached to your machine, the number of cameras and microphones the browser will admit to. There are the browser extensions you have installed, which some sites can probe for. Even the tiny quirks of how your browser handles time and math can leak. The point is not to memorize the list. The point is that the surface is huge, and every new browser feature is one more potential signal for a site to read. How uniqueness gets measured. So how does a site turn a pile of facts into a decision? The word to know is entropy, which is just a measure of how much a signal narrows you down. A value that everybody shares tells the site almost nothing. A value that only one browser in 1,000 has tells it a lot. Researchers measure this in bits, and the rough idea is that each bit cuts the crowd in half. Get enough high-entropy signals lined up and the combination points at one browser out of millions. The eye-opener, if you have never tested your own browser, is that a plain everyday setup is often already unique. No special software required. Check your own browser. You can feel this for yourself in about a minute, and I would encourage it. There are free public sites that read your own browser fingerprint and tell you how rare your combination is and how many bits of information it leaks. Open one in your normal browser, then open the same page in a fresh profile and watch the numbers move. It turns this from an abstract worry into something you can actually see. And once you have watched your plain everyday browser come back as one in a few 100,000, the rest of what I am describing stops feeling like paranoia and starts feeling like plumbing. Lipakins this, how sites link your sessions. Now the part that actually bites people running a lot of accounts. A site takes all these signals, passive and active, and hashes them into one identifier. Then it watches. Every session that shows up wearing that same identifier gets quietly filed under one entity, no matter how many different accounts log in from it. No matter how many times you clear cookies or sign out. Clearing cookies feels like wiping the slate, but the fingerprint does not live in a cookie. It is rebuilt from your machine on every visit. So two accounts that share a fingerprint are, to the platform, obviously the same operator, and that is the exact link that gets accounts banned in waves. How anti-detect browsers respond. This is the problem anti-detect browsers are built to answer, and the concept is simpler than the marketing makes it sound. Instead of one browser wearing one fingerprint, they give you many separate profiles, and each profile carries its own consistent set of these values. Profile 1 looks like one device, Profile 2 looks like a genuinely different device, and each one holds its story together. The user agent agrees with the canvas result, agrees with the fonts, agrees with the time zones. The goal is not some magic invisible browser. The goal is that each account lives in its own believable, separate identity that does not overlap with the others. And this is where the good tools separate from the bad ones. The hard part is not randomizing values. Anyone can throw random numbers at a fingerprint. The hard part is making a profile internally consistent and plausible. A profile that claims a high-end graphics card, but reports 2 CPU cores and the phone screen looks fake. And a fake-looking fingerprint can be worse than a plain one, because now you stand out as someone clearly hiding something. The browsers that hold up are the ones whose profiles look like ordinary real devices, boring and coherent, not a random grab bag of impressive specs. Why the proxy still matters. One thing worth being blunt about. The browser only handles the browser layer. It does nothing about your IP. If you run 5 spotless profiles all out of the same data center IP, you have linked them right back together at the network level, and all that profile work is wasted. This is why people pair these browsers with proxies, one clean network identity for each profile, so the IP story and the fingerprint story agree with each other. That pairing is the actual job, and it is also where I spend most of my testing time, because a browser that nails fingerprints but is a pain to wire to a proxy is not much use in the real world. What this can and cannot do. So let me be honest about the limits, because this is where the hype gets dangerous. No anti-detect browser is undetectable, and anyone who tells you otherwise is selling you something. Fingerprinting is only one layer. Platforms also watch behavior, how you move a mouse, how fast you type, your posting patterns, how old the account is, who you interact with. A perfect fingerprint sitting on an account that behaves like a bot still gets caught. And detection moves. What looks clean this quarter can be a known tell the next, because the people building these systems test the same browsers you do. No tool makes a ban impossible, and you should be suspicious of anyone who promises one. The honest limits on the other side. There are real limits on the site side too, and it is only fair to know them. Fingerprinting cannot reach outside your browser and read your real name. It works in probabilities, not certainties, so it produces a confidence that 2 sessions match, not a courtroom fact. Major browser updates shift everyone's values at once and pour noise into the pool. Privacy features in normal browsers keep pushing back on the easiest signals. So it is a strong recognition tool, not an all-seeing eye, and treating it as either pure magic or completely worthless will both get you into trouble. Where all of this lands, put it together and the picture is clean. A browser fingerprint is a stack of small, non-secret facts, the passive ones like your IP, your headers and your TLS handshake, and the active ones like canvas, WebGeo, audio and fonts, combined until the mix is unique enough to recognize you. Sites hash that mix, link every session that shares it, and clearing cookies does not touch it. Anti-detect browsers answer that by giving each account its own consistent, believable profile, paired with its own proxy, so the identities do not bleed into each other. It is not invisibility. It is separation done carefully. If we want the practical side of this, which browsers actually hold a profile together, which ones make proxy setup painless, and which ones quietly leak, that is exactly what I test. I run these tools on real multi-account setups and write up what genuinely holds up, honestly, with no undetectable promises and no affiliate fairy tales. The full written reviews and the picks I actually trust are all at antidetectbrowser.org. And keep whatever you build on the honest side of each platform's rules, because no browser and no profile makes a ban impossible. So understand the fingerprint first, and everything the tools do finally makes sense. They are not selling you a cloak, they are selling you separation and consistency, and now you know exactly what that means and where it stops. I am at antidetectreview.org for the tested reviews. Thanks for watching, and I will see you in the next one.